Hi, this is Mrs. Slater again. We are going to do the applications of base E and natural logarithms. And a common example of the use of E is the continuous compounding of interest. So continuously compounded interest is modeled by the equation A equals PE to the RT. Now, commonly known as PERT. You should know what everything stands for, so we're going to start there. A is going to be the final amount, and in this case we're talking about money, but later on in some of the applications we'll be talking about different things. So just think of it as a final amount versus final amount in money all the time. P is all the principal and beginning amount, rate for R, and T for time. And as always, the rate we're going to put in decimal form. So just be careful with that. And let's go ahead and start with our first example. Suppose we have $500 invested in 6% annual interest compounded continuously. You have to look for those words because there's other things that you learn in 12.7 with compounded quarterly and annually and so on that you've got to distinguish the difference between them. Okay, so whenever you see compound continuously, that means we're going to use base E, which is PERT. Okay, and let's go ahead and start by labeling. What do we know of all of our information? Okay, we know that there's going to be $500 invested, so that's our beginning amount. We know the rate, so that's going to be 6%. And then the time is unknown because it says when will we reach the investment of the ending amount, which is 1,000. So plug and chug that in, and I want you to solve. Go ahead and push pause after you write this down. Push pause and see if you can solve. Okay, so now we're going to divide both sides by 500. 2 equals e to the 0.06 times t. And we're going to take the natural log of both sides, just like we did in yesterday's notes. 0.06, or whenever that was. Take the exponent to the front, and then we know the natural log of e is just 1, so I'm not even going to bother writing that down. Divide both sides by 0.06, and go ahead and plug that in your calculator. And you should get t equals 11.56. Now, what does that mean? Okay, so that means after 11.56 or 11 and a half years, your $500 just went to $1,000 if it is compounded continuously. Okay, now the next one, it's a little bit of different information. Some of them are the same. Let's label what we have. Okay, the amount at the beginning is still 500. The rate is still 6%. The time now is 3 years, and now we do not know what our money is going to be like. Okay, so if we plug it into the formula, we have A equals 500, and then we have E to the 0.06 times 3. And we can plug that all in the calculator at once, and I'll go ahead and do a demo really quick. 500 second ln, because that's our e to the x. And then we have 0.06 times 3. Okay, and if you do not have a calculator that looks like this, make sure you put parentheses for that as well. Okay, so I don't know why I pushed it twice, but the answer is definitely 598 and 60 cents. All right, $598.61. All right, very good. So let's go to the next one. Investment service promises to triple your money. That's going to be handy to know if it's triple. Okay, and then in 12 years, assuming continuous compounding, again, there's your keyword for using PERT, what rate of interest is needed. So there's our unknown right there. We know that it is to be tripled. We know the time is 12 years. This whole triple thing, we got to think about a little bit. Okay, if I have an equation that is, for example, I started with $100. If I'm going to triple it, then I want the ending amount to be 300, right? You don't have to write this down yet. And then we'd have e to the r times 12. So that's what that would look like. So no matter what my first move is, it is always to divide by 100. And what will I always get on the left side? A 3. So you could just, if it ever said triple or double, you can always just use a 1 for the starting amount, and whatever they're tripling it or doubling it, In this case, tripling it, we'll just put a 3 here. So let's start over. 3 is our ending amount. 1 e to the r times 12, because that's our time. So now the exponential is always, it's by itself already, so we can take the natural log of both sides. 12r is going in the front, ln of e is just 1. So we just have to divide by 12. Pause and go ahead and find r. And then you should get 0.0915, but we don't want to leave our answer like that. We want to put it as a percent. So that would have to be 9.2% in order to get that. All right, go ahead and push pause, see if you can figure out this next one. How much will be deposited into an account that pays 9% annual interest? Again, keyword compounded continuously. Okay, and then to have a balance of 1,000 after 5 years. So that's everything that we know. Principal we do not. 9% is what we do know also. So we have 1,000 p e to the 9 times, nope, it's not 9, make sure we change it to decimal form, 0.09 times 5, okay, and then I'm going to have to divide by all of that because p is multiplied by all of it, and we can just divide both sides by that. And go ahead and plug that in your calculator, and since this is kind of a weird one, I want to go ahead and work that one with you. So you could find out it's 1,000, one more 0, and then divided by second ln, which is e to the x, and then you've got your 0.09 times 5. And there you go. So there's your final money after, that's what you would have to invest. So P is going to equal, whoops, 637.63 cents. $637.63. Okay, so let's go on to the next one. These are a different type of problem. It's going to be referring to exponential growth and decay. We'll focus on population with growth because we know at every second of every day that there is somebody either, there's somebody being born or dying or whatever. We're definitely growing, and we're going to use this one. Now, I do want to point out that if you use your book as a backup plan, the formulas I am going to stick with area A equals PERT, just to make it easier for our understanding, because A is still going to be the ending amount, P is still the beginning amount, R is the rate, T is time. So that is not going to change, but they are very more specific in your book, because they use like N and N sub O and P sub O. But again, I'm going to not use that, but it still means the exact same thing. Okay, so let's get started. What is A, what is P, what is R, what is T? A is the ending amount, and with the data that was collected, 36,894 people was at the end, and at the beginning, it was 25,784. It asked us to find the rate, so we do not know that. And the time, if you look at the years, you got 1985 all the way to 1995. So that is 10 years. Okay, so if we know all of that, we can plug it into the formula. And we have 25,784. E to the R we do not know, but we do know that it's 10. First move to make is to divide both sides by 25,784. That cancels out. E to the 10R. And then that's going to give you 1.4308. Take the natural log of both sides. Okay. And then you're going to divide both sides by 10. So you have natural log of 1.4308 divided by 10 equals R. So I'm starting to skip a little step, so make sure you're looking back at your old notes. Okay, and then once you find R, it's going to be 0.0358. Okay, so now for the predictions. I am totally out of room, so let's see if I can get some more room here. I'm going to erase this. Bring that up here. Okay, because it's asking for a prediction in 2013. So we've got A equals 25,784. E to the rate at which it's growing. We're going to assume that it's going to continue at that rate until 2013. And then how many years later? See, this was the data in 1985. How many years later is 2013? So just by a little bit of subtraction, we can come up with 28 years later. So that's what's going to go here in the formula. All right, plug all that in and then see if you get 70,315 people. And we're not going to have a decimal for people because that just doesn't happen. Okay? And go ahead and push pause, and I want you to work on the next problem. All right, so hopefully you got 178,890 people. So if you are off by a little bit, I just want to explain a little bit about what the calculator is doing, and maybe you're rounding differently than I am. So I want to talk about that a little bit. So look at your calculator. We're going to divide both sides by 6,400. We all get the same thing, right? And so then what I'm going to be doing, I round in my work, but then I don't really round at all in my calculator. Because if I take the natural log of the answer, now this is maybe a new thing to you. You go second, A and S. So it takes all of that information above and uses it. And then I'm going to close the parenthesis, and then I'm going to divide by 20. So even though I wrote 1.6, I really took everything that the decimal is. Okay, and then I get 10.27, and I forgot to divide, so that's a problem. And so all you would have to do is go second answer. Let's go second answer. Let's get that back. Oh, no, we don't want to do that. So clear. Second enter, and I just push enter there again. And all I do is second enter again. And there. You see what I did? I forgot the division sign, and that's happens. Well, we can fix it. And then that's where I'm going to get my rate. And then with that rate, once again, that is a larger decimal than what I have here. So I can put 64,000 and then E, so it's second log. And then I'm going to put in my 40 times, now watch this, second answer. It takes all of that decimal, not just some of it. So if your number was off, it's because you rounded differently than I did. And with the calculator, I did not round at all. That's exactly what you should get for that answer. All right, let's go ahead and talk about half-life. This one, these are a little different than what you're used to. But remember back when we did the triple. Think of that as the same concept here. So we have A, we have P, we have R, and T. So what they are given to you is the scientist orders radioactive bismuth. It's half-life. So if its half-life is 5, that's going to be the time. The rate we do not know. And then half-life would be if the beginning is 5, this amount at the end would be 2.5. So it would always be half of it. Okay, so if this is 1, then this will always be half of it at the end. Kind of like the triple, if you go back to what we did with the tripling of the account. All right, so if we know that we're going to abbreviate all half-life problems, because you're going to see that in your classwork, to 1/2 equals E to the RT. And now all we have to do is plug in the 5 that was given, and then we can figure out what the rate is going to be. So if you plug that in your calculator after doing natural log of E to the 5R, natural log of 1/2, you will end up getting R equals a negative 0.1386. So these are all going to be negative because it's radioactive decay. Okay, and then if we're going to make a prediction, okay, you'd have the amount, and then also you plug in the 224 that it was given, and then we'd have E to the negative 0.1386 times 30. And after solving that, you get 3.5 grams left. All right, and then finish the next one, and we'll talk about it in class tomorrow when you arrive. All right, the answer is 2,248 years. See if you can get that. Thank you very much. See you whenever.